So this question is about, we have given a number line here, like a number line we have been given here, and we have to paint the area which were required to paint. Like we have been told what, including areas which we have to do it, the painting. So there are many kind of paintings we have to do, but one of the more important constraint is that whatever area we have already painted, like this area. Suppose we have painting this area, and whatever area which we have already painted, and the next area which we are painting over the top, this area should not be included in that paint. We have to do one coat of paint on that. So the left and right, let's take here 1 and here 5. So this 1 is included and the 5 is excluded. Means the one painted job is here included, but 5 is excluded from this painted job. So it painted till this area, not this. So what basically we can do here is that we can think of a brute force approach with how much area we are going to be painting based on the past painted results. Like we can think of like painting this area and then this area, and if they overlap here, any kind of overlap happening, we can think of it like how like overlap. So we can like just iterate here, like if any kind of overlap, how much area it is overlapping, and we just add this result instead of this whole overlap area. So we can do that thing as in brute force approach, or we can say initial solution. But we can, one of the ways to think is that any area which overlap, like if this area overlap here, so any area which overlap, we know that we don't have to iterate through this. We have can we like instead of iterating through this, because this iteration could go for O of n, like the whole uh, situation could be like this, that we have to iterate through whole array, like n minus 1, like 0 to n minus 1, and last we know that it is painted aloud throughout the like whole. What we can do here was that instead of iterating to whole, we have to somehow reach to this point. So this is known as path compression, this problem basically. So what we can do here is that we can store it as in an array. This is a topic of prefix sum, if you can think of it like that, because the prefix sum or like prefix calculations, because we are pre-calculating most of the things here before the initial results. So we will just initiate these two pointers, any two pointers. Let's take anywhere. We will iterate this. So like any input we will get, we will iterate first on this, and after iterating this, we will get what is that the new painted area. We will just iterate it to initialize it to 0, and when iterating, we want the left and the right pointer to be like, we will we have the left pointer should be less than right pointer. Why? I will show you. The paint, if we are initializing this paint as this, and like paint any point where the L paint we take, and if it is unpainted, I will show you how we can deal with that. If it is unpainted, we will add a new paint to it, and if it is not, we have to reach to the location where it is painted. Like if this is painted, then we have to reach to this location to end this loop. What we can do here was that instead of like, if it is painted till here, like let's say it is painted till here, like r dash, it is here, it is painted, so we have to reach to this location, or it is painted till here, so we have to reach to this location. So we have to remove this unnecessary calculation of calculating this whole right. What we can do here is that we can maintain a this of paint array, and if that paint array is equal to that number only which we have initialized it initially, So we know that this is area is not painted. If it is painted, then we will initialize it to the last of the area which it is painted currently. So it is painted till 8, this is painted till 8, this is painted till 8, this is painted till 8. So we know that we can reach to that location without calculating this all areas which we don't need. So what we can do is that the painted area, for that the next location we will save like this, because we have to calculate for this, so we will save here 6. So next position will be the paint of that L. So paint of that L means the next position which we are taking. So next position will be this if it is not painted, or next position if we are trying to reach. Then that L part of that path compression, what we will do that if we know that it is going to be the position till this it is going to be painted, so we will just put it the position which it going to be painted, and we will start for the next pointer. So next pointer will be here, and we will start from here, and we will see the next position of that L. Like if it is not painted, then it will start from 6, and it will check like if this was painted or not. Like if this area could be like if this is painted till 10, or it could be not be painted, it could be painted till it is not painted yet. So we have to put this condition here to check that. So unpainted condition could be checked with equals to L, and we can just iterate through the start to the next pointer, and this will be like basically like what we've been doing. And the start, what we are referring to here, it is L. So L equals to next pointer position. So the start you can write here it as L. So um, the start is going to be here as L, and we will just add this result of the new painted which we are getting to the result we are getting for every every array, you can say, like the query which we are given. So we will get a answer result, and based on that we will don't have to iterate through these parts again and again. We can just remove this part, and this is known as path compression because of that, because we are compressing this path and going to the location which are not been previously calculated before. So basically the code would be like this. So I will use Python on this code. We can just iterate the max part to be this size, because we know that it is constraint is given as 5000, so we know that this is the maximum size we can get. So we just initialize it to these positions, and we can calculate it easily, as we will initialize it to 0, and we'll take this as it is raw, because we don't want to like handles that case, it's pretty simple. Like if path is outside that L, so it could not have happened, because if it is happened, like it is already been painted, and you don't have to paint it again, because if it is already painted here, whole whole it is painted, and left is R, so we don't have to paint till this like area, we don't have to calculate any of this. So if L is equals to new painted of that L, we will just, this is not painted, so we will just paint it, and the next pointer we will go to this based on the calculation we have done, and we will return the result.